So here we have part 4 of Laplace transformation. Let's do it quickly. In the last 3 parts, we saw Laplace transformation of algebraic, trigonometric, exponential and other types of functions and their multiplications also. So now we have some special types of functions like unit step function, which is very important, impulse function, periodic function. So first of all, we'll see what is a unit step function and then its Laplace transformation, and again we'll see a shifted unit step function and its Laplace transformation. So I'll show you here what is step function. So as the name itself is giving you idea, unit means 1, it means, and step functions means there will be a point, after that point your function will have value 1. You can see at any point after this point, at any point your value is 1, your value is 1, your value is 1. Okay, so that u represent unit function and it says u is the function of time. Okay, t means that. Okay, what is the meaning of shifted? When this red line will not start from here, when it will start from somewhere right side or left side. For example, in this graph you see our one value, this height is 1, I have shown here. This line is starting from this point, which is t is equal to a. So t is equal to a, so take a left side, so it will be t minus a is equal to 0. Okay, so this I am saying ut minus a. Okay, this time I am saying ut, now it is ut minus a, and because it has shifted to right side, so we can say right side shifted unit function, unit step function. Okay, so you can see this function ut will be equal to 1 for all the values of t greater or equal to 0. Okay, but otherwise it is 0, otherwise it is 0. You can see left side, otherwise it is 0, means less than 0. If t is less than 0, ut is also 0 for all the values less than 0. Same ways ut minus a is equal to 0 for all the values less than a. You see here red line, and for all the values greater than a, our ut minus a is 1. Okay, I have shown here. You see, if your function will shift to the left side, then like when t we will write less than minus a, so your value is 0, and for t greater equal to minus a, it is 1. Okay, so length is 1, here gap is 1. Okay, fine. So Laplace transformation of unit step function. So you can see I have defined the function here, right? Ut plus a is left side shifted unit step function, and this value is 0 at t less than minus a, and this value is 1 at t greater equal to minus a. Fine, clear. So now keep in mind, Laplace transformation of unit step function is this. If you are using u t minus a, or you are using your t plus a. So if you are taking minus sign here, then minus will come here. If you are taking plus sign here, then plus will come here. I hope it's clear, right? In same way, if you are using this function, which is just ut, then you substitute a is equal to 0, a is equal to 0, then you'll be having only ut, then put here 0, then it will be 1, so 1 by s. So now we'll see how to prove this. So we are getting this answer by using same formula. Let's see how. So we are choosing right shifted unit step function. Actually you can choose any one out of the 3, but for simplicity, like just to make it little worth proof, I'm choosing ut minus a. Okay, so as just now we have derived, I mean we have explained, we have detailed, ut minus a will be 0 when t value is less than a, and ut minus it will be 1 when t is greater equal to a. So we got our limits, right? Below a means till where? Below a means till minus infinite, and more than a means till where? Till plus infinite. Okay, so minus infinite to a first limit, and then a to infinite second limit. Okay, fine. So we are taking Laplace transformation of ut minus a, and in this limit our ft value, and keep in mind right now ut minus a we are using as ft, our ft value is 0, correct, in this limit. So I'm putting 0 here, so this entire thing will be 0, and here I'm putting 1, right, in this zone it will be 1. So multiply and integrate, simplify, you'll be getting this, right? And if you'll use plus sign, then plus will come here, okay, e power st by s. Now our topic is, this is how we can prove all the three answers I have written here. Okay, now we start impulse function. What is impulse function? So impulse means simply spikes, right? Impulse, like you have some information for at a particular time, or you can say very less time, like we can't count in integers, right? Okay, so again, unit impulse function and shifted unit impulse function. Shifted means it can be shifted to left side, or it can shift it to right side. Okay, so if it is not shifted, if it is simple one, it means at t is equal to 0 we have a jump here, that value is 1, that's why we are saying unit, and here at negative t is equal to minus a we have this jump of 1, okay, 1 means unit, and here at t is equal to plus a we have a jump, okay. So t is equal to minus a, take this minus a left side, so it will be t plus a is equal to 0. It means this is left side value, I mean this is left side shifted, okay, fine. So you can see here we don't have interval to get 1. Here we are like in case of unit step function, for entire interval we are getting 1, but here for a particular point we are getting 1. We don't have a complete domain to get 1, okay, in any all the three. At a particular time we have 1, fine. You can see here I have taken the, I have defined the function here. Keep in mind unit impulse function symbol is delta, okay, delta. So it will be 1 at t is equal to 0, it will be 1 at t is equal to a, it will be 1 at t is equal to minus a. It will be 0 when t is not 0. Again I am saying you to keep in mind, we are not defining any interval, we are just saying at what point t is 1, okay, I mean delta is 1, fine. So now let's find out Laplace of this. Put ft is equal to delta t now in the formula, but keep in mind this function can't be integrated under any upper or lower limit because we don't have upper lower limit, fine. So Laplace transformation of delta t, what is this? This is unit impulse function, fine. Okay, formula is this is our basic formula, what we are doing from the beginning. 0 to infinite delta t e power minus st dt. Okay, but this delta t exists only at t is equal to 0. So remove this, and no need to do this. You simply put t is equal to 0 in this, right? So we are putting here 0 and 0, and this will be 1. So I am getting delta 0, fine. So just now we have seen delta 0 means delta 0 is actually 1 here, right? Because exactly at t is equal to 0 delta will be delta 0, fine. So we are getting 1. That's why we are getting very clear cut idea as 1, delta 0 as 1. I hope it's being clear. So means Laplace transformation of any kind of unit impulse function, either this or this or this, any type, is always 1. Not only Laplace transformation, any other transformation also, like Fourier transformation, is also 1. For what? For which one? For impulse function, for unit impulse function. Okay, take one GATE question very quickly. In 2015 they told us, given that Laplace transformation of this function is given by this, and Laplace transformation of this we have to find out. A graph is given, okay, this function is ft and this function is t, okay. Keep in mind here they have given 2. If they will give 1, then directly it will be ut, but this time they have given ft, it means we can say 2 times of ut, correct, fine. Solution, again we have two approaches, either use direct formula or you use unit step concept. So first I will explain with the help of unit step concept. So using unit step concept, you see they have given line only from here to here, correct? So I have explained here, you can see the red line, it is going from here till completely here, right? So it is starting from 0, correct? So this red line I can show by ut, correct? We know this, right? This red line I can show by ut. In same way, this green line I can show by ut minus 1, correct? So if I'll subtract this green line from the red line, I'll be getting this remaining line. So that's why I'm subtracting. And if I'll multiply 2 in the entire thing, then this length will be 2, correct? It means equation of this given line is nothing but 2 times of ut minus 2 times of ut minus 1. I hope it's being clear. Okay, so we got the equation. We got the equation of this function ft. So I'm writing this function ft, we can write in this way. And then take the Laplace transformation. So ut, it's very easy, 1 by s. Ut minus 1, it's again second shifting property, e power minus s by s. That's all done. We got the answer. This is one way to approach. Another way is by using formula directly based on direct formula. So Laplace transformation is 0 to infinite e power minus st ft dt. But our ft is not defined from 0 to infinite. It is only defined between 0 to 1 and answer is 2. Okay, you can see the graph again. In the question, they have defined only from 0 to 1. So that's why we are keeping limit 0 to 1. And in that limit, what is the value of ft? That value is 2. That's all. Now it becomes simple integration. Like integration is 0 to 1 e power minus st into 2 dt. This is a simple one and we are getting this as answer. I hope it's been clear. Okay, so for your doubts, text me on Instagram. I will put my link, profile link in the description box. Okay, so thank you. Go for the next video.